Hey AP Stat students, Mr. Tan here to help explain the 2020 sample question that I posted earlier this week. So I want to go through some possible answers with these questions. First thing we're going to do is just take a look at question 2. So a reminder, question 1 is a little bit longer on your test next week. That one is about 25 minutes, and then the second question is about 15 minutes. So you're going to submit after question 1, submit that, and then you're going to go on to question 2 and then submit that. So this is a sample question 2. So one of the things, since there are only 2 questions, these questions are going to combine several different aspects of or content of the class. So this sample gives us a table. So students at an agricultural station conducted a study to compare genetically modified corn with regular corn. Each of 33 plots of land was divided into 2 half plots. One half plot was randomly selected to be planted with GM corn, and the other half plot was planted with regular corn. The table shows summary statistics for the yields in bushels per acre and the difference in yield for each plot. So you can see we have these summary statistics, and if you look at those, they give you the mean, the standard deviation, the sample size, and then the 5-number summary also. So I'm going to go through some possible suggested answers I wrote up. I'm not promising these are perfect, but I think they'll give you a good idea of some of the important concepts here. So question A says, explain why the yield from one type of corn are not independent of the yields from the other type of corn. So with this one, we want to take a look back at the original question, the setup here. And what we're doing is we're taking a plot of land, actually 33 plots, and then we are breaking those plots into half plots. So the 2 types of corn are being planted in every plot. So every plot has both types of corn. So remember, independent means there's no association between the types of corn or the yield of the corn. So I'm going to show you what I wrote for that answer. Said the yields of one type of corn are not independent of the yields of the other type because both types of corn were planted in the same areas and land. So the corn was grown in the same way, in the same place, in the same area. So there definitely is an association between these two types of corn and the output of those types of corn, or the yield. The other thing that you might want to mention there is they both are experiencing the same weather patterns. They're experiencing the same growing season and growing conditions. So definitely there is an association between those. The second question, let's go back to our second question. So our second question asks, based on summary statistics, would it be more likely to obtain a yield of 123 or more bushels per acre from a plot of GM corn or a plot of regular corn? Justify your answer. So with this one, what we want to do is take a look at these summary statistics. Now I focused in on the medians, and one of the things I noticed is that the median of the genetically modified or GM corn is much higher than the regular corn. And so we're looking at 123 as our cutoff here that they're asking about. So since we have a median in the GM of 127.5, that tells me, remember the median represents the place where we have 50% above and 50% below. So that tells me that at least 50% of the GM corn, or 50% of those yields, were above 123 because we have 127 versus the other one we only have 119.4. So here's what I wrote for that one. It said GM corn is more likely to obtain a yield of 123 or more bushels per acre since it has a median of 127.5 bushels per acre. GM corn has at least 50% of its crop over 123. On the other hand, regular corn has a median of 119.4 bushels per acre. This indicates that less than 50% of its crop had an output of 123 bushels per acre or more. So it gives you an idea of what we could do there. And let's go on to the third question. So that third question, it gives us a box plot, and it asks us to describe this distribution of differences. So remember, when we think about describing distributions, and it's very likely you're going to need to describe a distribution or compare two distributions on your two questions next week. That's a huge thing in AP statistics, just understanding kind of key components of distributions. So we use this acronym SEX in class. And so remember, the S stands for shape, the E stands for extreme values, the C stands for center, and S stands for spread. So there are two S's there, one shape, one spread. That doesn't really matter as long as you remember both. So the big three definitely would be center, shape, and spread. You have to hit on those three things to make sure you do a good job explaining this distribution. So here's what I said with this one. When I look at the center, I notice that the center looks to me at about 3. I notice that this, in a box plot, remember this box part contains about 50%, or it does contain 50% of your data. So we know at least 50% of our data, or about approximately 50% of our data, is between about -1 and 6. And I also know that I have this dot here. Remember, that's an outlier. So here's my response for that question. It said the distribution of differences. I'm going to move myself out of the way here. There we go. The distribution of differences has a middle or median difference of about 3 bushels per acre. About 50% of the differences were between -1 and 6 bushels per acre. Although shape is tough to see on a box plot, it does appear that this distribution is skewed right. You can also see that based on the fact that the median of differences is larger than the mean of the differences is larger than the median, that indicates that we have that skew to the right. So just a reminder there before we go on, if I know, remember, the mean is not resistant to outliers. So I know that if I have a mean that is larger than my median, that indicates it's skewed to the right. If the mean is less than the median, it indicates skewed to the left. So I compared those on that summary chart. And then finally, I said there's an outlier of 20 bushels per acre. So I've hit on all the things up here, S, E, C, S. The other thing that's very important is that we always include context in our answer. By mentioning bushels per acre, I probably could have done even a better job here of adding context now that I reread what I wrote, because I don't mention corn, but I should definitely include something about corn also. But any answer we write, to really make it quality, we want to connect to that concrete situation. Okay, going on to that next question, part D. So this gives us a set of hypotheses. And so we are saying that mu sub D is the population mean difference in yield in bushels per acre for plots similar to those used in the study. So the conditions for inference have been met. So we don't need to worry about addressing all those conditions in this question. But in D, it says one of the conditions for inference that was met was that the sample size of the differences is greater than 30. Explain why it is necessary to satisfy this condition. So thinking about that one, first thing I wondered about is, does it mention anything about being a nearly normal distribution? And we really don't have anything up here that mentions the idea that it's distributed normally for the GM or the regular or the difference. They do give us this box plot, some summary statistics, but we really don't know that. So that 30 number becomes important. And here's what I said. So it's important to have at least 30 because we can't be sure that this distribution is nearly normal. It may have skew or outliers, but when n is greater than 30, the central limit tells us that we can still apply a normal model. So I indicated that this wasn't necessarily normal, so we could apply the central limit theorem. We did activities earlier this year where you saw that no matter what the shape of the distribution, if I have a large enough sample, eventually that distribution does become normal. Okay, and then finally on part D here, the test resulted in a p-value of 0.0003. Based on the p-value, what conclusion should the students make? So reminder, p-value is the likelihood in general of getting our result if the null hypothesis is true. So the probability of getting the result we got if that null is true. So in this case, if there is no difference, if the mean difference is 0 in every one of those between the genetically modified and the regular corn. So here's what I said about that. I said, assuming there is no difference between the output of regular corn and GM corn, the probability of getting the mean difference we got is about 0.0003, or very unlikely. Thus, we would reject the null and conclude that there is a difference between the mean output of regular and GM corn. So it's important that you can interpret the meaning of a p-value if they give that to you. Again, I would say that's a very likely a type of question. Not necessarily in this type of test, but in some other test. Maybe it be a 1 proportion or 2 proportion test, or maybe it would be a test for one mean, one population, a single population, or a single sample. So just make sure you know how to interpret that p-value for your test next week. So that's really the main points on this practice question. This was just a question 2. They did not give you a question 1. Now, I also gave you another set of 2 questions from the StatMedic website, and I'm going to scan and include a key to that. I decided not to make a video because the key is quite detailed on that one, but if you have questions, feel free to email me on either of these. And keep studying AP Stats because you have 1 week left before your test. All right, take care.